So now you've taken those drives out of your Pelican cases, you've uploaded it into your analysis capability, you've taken the original drives and you put them in your evidence lockers, and now you're going to begin to mine those images for whatever it is that you're looking for. That's where we are in the story. So you're talking about confirmatory analysis. Are you going to be able to confirm or refute the fact that there are, in this case, credit card numbers in that system, whatever that turns out to mean? So you want to transform the huge amount of data that you might have collected into a much more manageable size that you can do something with. You want to do an initial survey, extract the relevant parts, and then do the examination. So you got to know the image device, whatever that means. And I think back of CSI, crime scene investigation, back in the days when William Peterson was on the show, and they took this unknown substance, they put it in the gas chromatograph or spectrometer, whatever it was, and it comes out with the chemical makeup of whatever it was that we're looking at. The technician reads off, it's got this, it's got this, it's got this, and Grissom says, it's pink lipstick. Now, maybe it doesn't happen that quickly, but the bottom line was, by taking the initial data of the components of the unknown, he knew what that meant. And when those chemicals were put together in that fashion, it was pink lipstick. So the challenge in doing the analysis is to take all the signs of data. You know, a USB was plugged in here, this happened, this happened. What that means is that this is what happened on the system. So that's the idea. So at this point in time, what really happens in forensics, it really means, do you know how Windows works? Do you know what Windows keeps behind that allows you to mine it for data? So it's called Windows forensics, but it's really Windows, do you know how Windows works? Do you know what registry keys Windows writes when you plug in a USB device? And do you know what the fields mean? Do you know what the prefetch is in Windows? So at this point, if you have to most cases have to understand what Windows means. Okay? Then you get into these other devices. Where does an Android keep good stuff? Where does an iPad keep good stuff? So then it becomes really understanding the device specifics. So you're analyzing the imaged information. You need an analysis platform. That analysis platform probably has gobs of disk space. Ours has 100 terabytes today, which gives us some room to do things, because we have multiple law enforcement people working on multiple cases at the same time within the same hardware. Lots of disk space that needs to be wiped so that you don't cross-contaminate. Lots of processing power because you're going to do indexing, and we also have a decryption cluster. I think we have 20 or 30 machines where we use some commercial decryption software to try to determine passphrases for encrypted assets. We have pretty much all of this. This is where are some specific tools. FTK from Access Data is a commercial tool for doing forensic toolkit is what FTK stands for. NCASE is from Guidance Software. We have that as well. We also have a PTK, SIFT from SANS. If you happen to take the SANS forensics course, they provide a VM that uses public domain tools. It's called SIFT. And one that I maintain is called the CERT Forensic Appliance. And we're working to change the name of that piece of software to ADIA, A-D-I-A, which stands for Appliance for Digital Investigation and Acquisition. That's also on our website. It's a Fedora 14-based virtual machine where you can do analysis using all freeware. So if you haven't done a lot of forensic stuff, you want to image your home computer and look at the image, you can look at the image under the appliance and learn how to do more forensic analysis. We also have lots of specialty tools for doing registry analysis and our good old friend timelines. Remember, you're telling a story. There's lots of timeline tools that will give you all of the changes through the file system, all of the changes through the registry, superimpose log files, and you can see everything that changed on your system and begin to construct what happened. Okay? Traditionally, what you'd find in a lab that's doing forensic analysis is every analyst has a big beefy computer with a gazillion types of connects and a whole bunch of local disk space. And so when they're doing like an FTK, they'll upload the images, they'll do an FTK, they'll get coffee, they'll drink coffee, they'll get more coffee, or they'll start it on a Friday afternoon and let it run over the weekend. By the time they come in on Monday, FTK is indexed everything, and they can do their analysis. So the workflow is typically serial: upload, index, analysis. So what we have put together is something called CCAP. And this is not a product. This is what we have built, which is the Clustered Computing Analysis Platform. And essentially what you do is you attach to examination machines using remote desktop protocol, and you can start one thing on one machine, start another thing on another machine. You can be working on multiple cases at the same time without worrying about cross-contamination of data, etc., or network activity. So that's what we have built. This is 100 terabytes of storage that's in our machine room. This is probably 5 racks of equipment that do very special things like examinations, like password cracking, maintaining the machines, et cetera, et cetera. And federal law enforcement has access to this and have used this in doing various and sundry cases. Dell has a product that has similar characteristics to this. That's a commercial product that you can buy. My understanding is theirs is tuned for FTK and takes advantage of Dell products. Ours is application agnostic, which means we support FTK, we support EnCase, we support the forensic appliance, we support a whole bunch of things. You can pick and choose from what you know and what you've been trained on in our environment. Dell's uses FTK and is optimized for FTK.
The password cracking now, that thing can run forever.
That's right.
How powerful your
Right.
cluster. But is it any policy like, oh, okay, it ran for 30 minutes and then we just gave up on that?
Right now, it's a manual operation. Somebody has to introduce a password cracking task into the cluster and then monitor it. And based on what our partners have defined as the amount of time, which translates into money, that they want to spend on cracking, we'll just let it go and they'll pull the plug whenever it makes sense from their perspective. But you're exactly right. It may end, it may never end. And we are using commercial products to do password cracking. We just have, I think, 30 machines in the cluster, and I think they're all 8-core. So that's effectively 240 machines available to the cluster. But you're right.
And this lab is in
Yes, this is in the Software Engineering Institute on Fifth Avenue, and it's in the basement. So one of the things is, since it uses remote desktop as the way to connect to it, you can have a pool of resources that happen to be located in Pittsburgh. You can have agents here, you can have agents there, and they can all be using the same data. Whereas in the traditional approach, typically it's in a lab, and you have to be where the lab is to gain access to the data. We use strong encryption with RSA tokens, the new ones based on the problems RSA had last year. We've updated those. And remote desktop is the way to get to it, and Cisco IPsec VPN. So encrypted communications, strong authentication, and remote desktop for access.
So essentially, we would be, or law enforcement would be able to try things out remotely, even in like a teaching scenario.
Yes. Yes. Exactly the case. So as I say, we provide all of these sorts of things, and findings presentation development tools. That means open office, or so that you can write a report. All that stuff contained in there, and it's a Windows 2008 server environment. That's the desktop that you get when you log in. So in the process of doing, as I've said many times so far, in the process of doing that analysis, you're building a story. The story is keyed on a timeline. So a timeline is an ordered list of changes on the device when things happen, and you can use this kind of information. For example, modified access and create time of files. Only the last MAC time is saved, so you can't see intermediate changes. You only see the last time stamp. You can zero in a specific period, and this information can be made to be file system independent. Like the sleuth kit, for example, can mine this information independent of the file system type. And this was actually created a while ago because now there's ext4 in the latest Fedora 15 and beyond. So essentially what you're doing in the analysis is you're looking for what you're looking for. In the case of, for example, child pornography, you're looking for pictures that are of the right type. So something like FTK, if anybody ever used FTK, FTK will give you all of the images it finds in a disk. Then you sit and you look at those images and say, that's what we're looking for. This is where I found this. Now I write up the report and I'm done. So it can find all of these various specific things, files with strings in them, and you may be looking for files that change around the time that the event in question happened. Counterforensic tip 4. There are tools that hinder forensic analysis. They clean up. One of the key things about a forensic analysis is deleted file space. So the counterforensic tip is, let me, when I delete a file, securely delete that file. So securely deleting a file amounts to writing zeros over it. Then when I've deleted it, it's been securely deleted, you can't find it, you can't find what happened. Now, there are a whole bunch of them that work in different ways. These are examples. This one is an example from Evidence Eliminator. This is a tool that we used to provide on our website that we don't provide anymore, although I suspect we would provide it if the conditions were appropriate. And what it does is it looks for signs of certain tools that have been added. Now, as a forensics analyst, as an analyst of digital evidence, you'd be nice to know if the suspect had access to counter-forensic tools, because you may save yourself a whole bunch of time. I don't need to worry about deleted file space. There's not going to be anything there. It would be good to know that. That's where Apereo fits in. Another thing you can do, and specifically in the case of a Windows system, you can go through and try to reconstruct what you think you'd see if you sat at the screen of the machine that you just imaged, or you could run it in a controlled environment. That tool is called LiveView, which is, as it's on SourceForge, there's another version that's on our website, and essentially you take a DD image or an EO1 image of a Windows system and transform it via LiveView and run it under VMware. Then in the case of the law enforcement version, it zeroes out the admin passwords and all the passwords, so you don't have to worry about credentials. Then you can just run the image and see what the person would see on their screen. Now, when you run a system, you have passwords squirreled away that may be in for example, the Firefox password manager or some other places where credentials may be stored within Windows. If you can run the system, magically those tools pick up the credentials from the credential cache in Windows and you get to see them. So if I can do something like this, I can make finding credentials a lot easier. You understand what I'm saying? Very quick, free tool for law enforcement, still under development, still being changed. So it only deals with Windows images. It doesn't do a Mac image. It doesn't do a Linux image at this time. Okay. So it's very easy to use. Contained within the ISO image that you would download from our website is how to install it, how to operate it, etc., etc. The image that you run does not have a network connection, so you don't need to worry about it reaching out to the internet and destroying itself or doing something like that. The network device is removed. So it supports all of these systems and under these versions of VMware and VMware Server. So essentially when you're doing an analysis, if you've never done one, is you find one thing that leads to another thing that leads to another thing and so on and so on. And what you as the analyst are doing is keeping track of each thing that you find. Oh, I found this here, and this led me to here, and I found this. Things like NCase and FTK let you keep bookmarks where you can arrange your findings in a way that makes it easy for you to find them. And the key thing about findings is they should be able to be repeatable by somebody else. Eventually, in a court system, what's going to happen is you're going to turn the evidence over to the defense, who's going to have their own experts who do the same stuff to try to validate what you found. Hence the notion of repeatability. So, and that's where I'm saying you got to know how Windows works. You got to know where Windows stores stuff. so that you can make sense of out of what you've got. So is knowing the specifics of the items being analyzed. And people who do this know how Windows works, know what changed from Windows 7 to Windows 8, know what changed from snow leopard to lion to find the good stuff in the right places, and know all this stuff about where PDAs keep things in the apps file system under an Android and what that means. So one of the things you can do in the process of doing an analysis is take this mountain of stuff and separate it into two piles. That which we know about and everything else. And one of the things that, for example, FTK has is this known file filter. Or if you know about the National Software Reference Library from NIST. These are checksums of files that are known to come from the vendor and other people. So you can partition what you've got into, I know what this is, I don't have to worry about it, and everything else. Because the key analysis technique is to take a whole bunch and whittle it down until the part that you really need to deal with. And then also knowing something happened. And constructing timelines and seeing what files changed around the time of concern. Okay. There's this notion of slack and unallocated space, which typically has files that have been deleted. That can be important in knowing, gee, they FTP'd this file, they operated on it, they deleted it, now I can go find the original file. You may find, what is pagefile.sys? Anybody know what that is? What is it?
Just a driver which operates the page file, like swap memory.
So if a file was in memory and it got swapped out, it's going into file. What's hyperfile.sys?
Just for hibernation.
Yeah. So when you hibernate a machine, close the top, it keeps an image of memory. There may be really good stuff in there. Event logs, and there may be also software-specific logs. One software-specific log could be the logs for IIS on a Windows machine. That's the web server. The big two for doing analysis are FTK and NCase. And what you end up doing is you end up having to know how, they don't tell you how the operating system works, but to mine the information you need to use that. Okay? And you index stuff and you go find stuff. And it pulls out, like, give me all the pictures. Give me all the email conversations. Give me all the IM streams. And I want to go mining for that information.
So, but the experience with NCase limited, but it would extract deleted files as well, or just parts of those deleted files as well. So basically, it's raw data from hard drive or whatever media you. Okay, so.
Yeah. I mean, imagine you walk through every file on your disk and you said, this is an executable, this is an image, this is an email file, this is an I don't know, and I found this stuff out in deleted space, and it's an image, or it's an executable, or it's zip file. And at least FTK, and I'm sure NCase works the same way, lets you see all of those by the type of file that they are. Yeah.
Detection, or people hiding things in alternate data streams and things like that. Does FTK and NCase do that automatically?
Yes. Yep. And then you can walk through the registry. But the challenge of the registry is knowing where you're going. Where's the good stuff kept in the registry? And that's why knowing how Windows works in most cases is important. So other common applications are hex editors. I don't know what this file is. Let me get into a hex editor and see if I can figure it out. Maybe there'll be some good stuff in there. We talked about memory analysis with volatility. There are tools for dealing with capture analysis of memory. Encryption, PRTK is one. CryptTool, if you haven't had a chance to play with encryption, CryptTool is free. Go download it, go play with it. You can do wonderful things with CryptTool. Viewers, image analysis, VLC is a good tool for doing image analysis. Browsers will also do that. It may be helpful to write. Our guys tend to write a lot of custom scripts when they need to do something specific. Trying to think of a good example, which I can't come up with, but they write them typically in Python. So if you were to sit down and learn a programming application as an analyst, my suggestion would be learn how to use Python. It's a very good, you can do GUI stuff with it. That's good command line, whatever. And then we provide these environments. So forensic appliance, we've talked about providing SIFT. And anyone know what SIGWIN is?
Yes, it's Linux running on a
It's essentially the Linux API running natively under Windows. So if you have just a Windows box on your desk and you want to run some Unix tools, install Cygwin, which you can do without administrative privileges. I'm not telling you to do this if you're not allowed to do this. You may have rules that say you can't do that in your office, but you can get all the native Windows and Linux tools running natively, including compilers, including the X Windows system, including Python 2 and Python 3 and GCC and all this stuff, running natively under Windows. So you don't have to decide, am I Windows today or Linux? You can them both. And we provide that in our analysis environment. So what you're looking for when all is said and done, good, is the evidence that you're looking for what you were told. You got the warrant, you're looking for this. In this specific case you're looking for credit card numbers. Now there's a tool that we are writing that we've used that will become available to law enforcement. It's called CC Finder. And you give it a hunk of stuff, like a file systems tree, and say, go find valid credit card numbers. And it will find valid credit card numbers that match the rules for forming credit card numbers, 15 or 16 digits, et cetera, et cetera. So that would be a relatively easy one once that tool is available. You construct a timeline, and then here's the collection of tools that you can use to do your analysis. Take notes, report findings, timestamp, date, initial. Don't rely on your memory. And as you get older, rely less on your memory. Trust me, I think. Okay. So that's analysis. All right, so that's where, so essentially within the example that we're talking about, the belief at this point is that you mined what you took from Denver, you brought it back, you put it in your system, you look for credit card numbers, you either found them or you didn't. And if you didn't find them, that's not very interesting. So we'll assume that you found some valid credit card numbers in that data stream. And then we'll do the next thing after the break. Yes?
Okay, so a big thing nowadays is pictures, right? People take pictures with their phone,
sure,
and then they upload them to their computer.
Sure.
Do you have any tools that kind of goes through literally thousands of pictures that people have on their personal computers in case of evidence? Like, do you have something to
Well, FTK will do that. FTK in Ncase will go through and give you all of the pictures it finds on what you're...
I mean, you know, who's going to want to look to 50,000 pictures? I mean, I'm just guessing.
We have hypothesized something that I call CP Finder, which is short for Child Pornography Finder. Because if you're looking for skin tones of a certain characteristic within a picture, so it may be possible to take the 50,000 and weed them down to 5,000 that have people in them.
I've seen something like that, but I'm like wondering if you know, you have so much metadata in pictures, maybe classifying them by metadata,
yeah,
or you know, even Huffman coding, things like that.
I'm not aware of automated tools that do that. That's why we provide Python and Perl so that you can sit down and sort of roll your own. There may be a way. I don't have much experience at all with Ncase, but were there scripts? N scripts, I believe, is what they're called in Ncase.
There are. I mean, what you're looking to do. I mean, if you have 50,000 image files and you're looking to hone in on just a specific few automatically, that's going to be almost impossible.
Because let's say if I wanted to say every time somebody was at this GPS location or in this vicinity.
That's if the capturing technology has the ability to record that data. I mean,
so let's assume that
you would create a script, like say, you know, hey, you want to be an image file containing this information.
You can, if it's in the metadata, then you should.
Or even something like fingerprinting a type of not a type of a camera, but a specific camera. Let's say you want to know that we both have iPhones, same type, purchased on the same days, you know, but my camera as opposed to his took this
serialization.
There is a way. We have a shop that specializes in cell phone forensics, and they're one of the leading, group of guys that actually do this in the country. Okay. And they do have ways to go in and say, I've got four Apple iPhones, all the same manufacturer, same vendor, same store, down to the serial numbers, one apart. They can tell you which phone took the photos, where the phone was at when the photo was taken, and who took the photo. And they can go that.
Because I mean, I've always thought that if you could do something like that, then you could go on the internet and actually, you know, kind of track, say, this picture found on this site was taken by this phone, you can kind of,
Sure.
you know, say this
Right.
child photographer, you know,
Right.
took these pictures exactly, trace it back
Yeah, you
to
could
them.
trace their path through
Yeah, through
geography.
the internet.
Yeah.
Really.
Yes. I mean, all the data's there. I don't know if there's something that says,
Yeah, because I've never seen, you know, I'm sure that maybe custom or LEO or
Yeah.
law enforcement stuff, but I've never seen open
I don't think it
source.
would be that hard given the metadata to actually show me the path and show me the time. And a time elapsed photography is what I'm thinking of, that shows the person. They went to Denver, and then they went over the mountains, and they went to Grand Junction, and they went up to Salt Lake City, and they took these pictures, and I can reconstruct that sequence of events from the metadata and pictures. I don't think that would be hard. I think all the data is there. If the data is there, if it's being recorded, then it's there. That would be pretty cool.
I've seen
Pretty dumb of it.
students in school that they've been able to efficiently scrape all the EXIF data, but through Huffman coding, you know, be able to find patterns and things like that to track, you know, specific.
Yes.
cameras.
Well, doesn't Google provide some, you know, tell me what this is a picture of?
But they usually use EXIF, and if you could scrape that, which
Yeah.
isn't that hard to do.
But I thought they're doing it based on pattern recognition also.
That
Somebody's
is right.
doing that.
Yes. They have the Google image
Google
search.
goggles or...
Yes, I know exactly what you're talking
Yeah.
about. Where you can upload a picture and it'll tell you where it was taken.
Right.
According to exactly. I've seen
Yes.
it. It's pretty amazing.
Yeah. Okay, other questions? We've got about 15, 20 more minutes of this after the break, and then we'll head into the malware stuff.